In this instructional video, we will be recreating Training Plan 2, which is accessible through Open Sample projects. Let's review what we have in this project. We have a relatively simple L-shaped house with a gable roof over the main structure and a hip roof at the garage. This is what we'll be recreating. Let's create a new project. Use the default project name, or create your own project name. Let's call this Training 12-3-2025. Click Create. Be sure to specify the applicable design codes and presets as you are setting up the project. To get started, we are going to right-click and select Bearing Envelopes. Define your bearing height and thickness for the walls. I'm just going to use the defaults here, but be sure to specify properties to meet your project requirements. We're going to use the direction and length input mode. Let's start with 30 feet to the right. You can either hit Insert and repeat or simply use the keyboard's Enter key, which I'll be demonstrating. So we're going to click down 12 feet and press Enter. Right 21 feet and press Enter. Up 20 feet and press Enter. Up 15 feet and press Enter. Then left 51 feet and press Enter. And then to close this out, we can use point selection and snap to our point. Click Insert and Close. Let's change our garage walls from 2x6 to 2x4. Hold down the Control key to filter selection to bearings. Holding Control, I'm going to select my bearings by dragging the mouse. Change the thickness to 3.5 inches. And now we'll input bearing envelopes again. Right-click, select Bearing Envelopes, and change the thickness to 3.5 inches. This time, we'll use point selection mode. I want to change the justification for the wall to be placed in the correct location. So I'm going to change that to back. I've got orthogonal turned on. So I'm going to click there and select Insert and Repeat. I need to change justification to front. Click the endpoint and then click Insert and Close. The next thing we're going to do is to put in our roof planes. Right-click, select Roof Plane. We'll define the slope as 612. We'll go with a 1-foot overhang. You can use standard butt cut method or use the heel method to force a specific heel height. Let's use the heel method and specify a 6-inch heel. The most efficient way to input planes repetitively is to hold the Alt key and click on the wall to place a plane. Repeat for the other gable plane. And then on the garage, we're going to put 3 planes defining the hip. There we have it. Press Escape to exit plane input mode. It's possible to cut planes individually, or you can use Auto Cut. Let's try Auto Cut. First, we need to select all roof planes. Then select Auto Cut. It did a pretty good job. However, we wanted this rear plane to be cut as a gable. So I'm going to select the plane, recut the plane to come along this gable wall. Hold down Shift and select the gable wall. We're going to cut against this other plane by clicking the plane. Hold down Shift again to cut against the left gable wall. And click Finish Cutting. We need to recut this right garage plane next. Select the plane, right-click, and select Recut Plane. I'm going to cut against the garage planes and the main front plane to create this valley. Finish cutting. We need to recut the final plane to include the valleys. Select the plane, right-click, and select Recut Plane. Shift-click the left gable wall, click the rear plane, shift-click the right gable wall, and then click the side garage planes to create the valleys. Click Finish Cutting. So now that our planes are cut in, we can see what that looks like in 3D. Use the right mouse button to pan and rotate. The next thing we're going to do is to put in some trusses. So we'll right-click and select Truss Envelope. I'm going to put in the hip girder first. I'm going to define this with a 6-foot setback by typing 6 feet into the snapping distance field. Using the Lock to Base option may help. Click the front garage wall as the base and drag the mouse until you get to 6 feet. We want to make this a 2-ply. Click Insert. With the hip girder selected, we're going to create our corner sets. Right-click and select Corner Set. We need to select our corner set planes. Select the girder again. Right-click and select Create Corner Set. Pick your corner set planes. Now that the corner jacks are in, we need to create the end jacks. I'm going to right-click on one of those corner jacks. Click Start Run. Move the mouse over to place the end jacks. Repeat this on the other side. That's terrific. So we've got our hip system in. Let's continue adding trusses. There are a few ways we could frame this, but I'm going to define a girder truss here at this wall. We're going to make that a 2-ply. We'll need to adjust the justification for the proper placement. Once placed, click Insert. In this particular case, you can see the left side of that truss picked up the other plane as the overhang. So we need to redefine the left overhang as 0. Next, we need to put in the remainder of our trusses at the garage. Let's right-click, select Truss Envelope. We'll lock the base, change snapping distance to automatic, and select the side of the girder. Move the mouse as you see fit till you get to 2 feet. And in this case, I'm going to insert and start run. We're going to drop in a truss here. As a best practice, you'll want to be intentional about the placement of your trusses, which we are taking some liberties with this example. Let's right-click and select Truss Envelope. I'm going to insert a gable end here. Click Insert and repeat. Select the other gable end wall. Move the mouse until you are able to properly place the truss. I actually want the left end to be on the other side. So we'll flip envelope, and then I'm going to insert and start run. We can run these trusses all the way over. And there we have it. Let's turn on our solid truss view and review in 3D. We can see that these trusses here have picked up the garage planes. Let's address this, assuming there will be overframing in the field. Again, we can hold the Control key. We'll select all of these trusses and then add a top cut from the properties. Select the front roof plane. Let's take a look in 3D view. We have not yet added a vault. We will do that later after we initially design these components. So with our 3D geometry defined for the building and the trusses, we can go up to the Project menu. Select Design All Truss Envelopes. We can change our truss view to Designs and explore the layout in 3D view. These trusses have all been designed with the default webbing configuration. From here, we can analyze all changed components. All trusses pass checks. Next, we'll create our IFC download. Click Download and select Layout IFC. The IFC file will save to your downloads. You can import the IFC file into other applications such as Revit or other IFC viewers. Here we have the IFC file opened, and we can see the trusses as we spin around. Everything looks great. Now that we have our trusses designed, we're going to introduce a vaulted ceiling along the left side of the gable section. Let's right-click, select Ceiling Planes, and define Slope as 312. Holding down the Alt key, click to place the ceiling plane, and then Alt-click the other wall for the second plane. Make sure visibility is turned on so you can view the ceiling planes. Next, let's cut the ceiling planes using a similar process as with roof planes. Select the ceiling plane, right-click, and cut plane. I'm going to hold down Shift to cut against this wall. We're going to select the front plane, hold down Shift to cut along the left gable wall, and click Finish Cutting. We'll repeat by cutting the other ceiling plane. Right-click on the ceiling plane, then Shift-click to get the gable. Next, click the rear ceiling plane. Hold down Shift and click to get the bearing edge. And click Finish Cutting. Take a look at this in 3D. We can see that the planes are properly cut in. Notice that the component designs don't automatically conform to the new ceiling planes, though the truss envelope solids do. We'll need to regenerate the designs to recognize the new ceiling planes. We'll hold down Control again. Select these trusses by using Sweep Select with the mouse. Right-click, and now we can regenerate our components. Enable 3D view, and we can see our truss designs are now vaulted. We're going to analyze all changed components. They all pass checks. This is when it's suggested to review the individual trusses. Finally, we can download individual component IFC files for selected components, or we can download the layout IFC, which includes all the layout trusses, including the updated scissor trusses. The IFC files output to your Downloads folder. From there, you can bring them into any application that imports the IFC format. Let's take a quick look at our IFC file for an individual truss. This looks great. And here we opened up the IFC file for our trusses where we added in our vaulted ceiling. We see the list of trusses along the far right, and the member number associated with it came across. These look great as well. And that will do it for this instructional video. Thanks for watching.